Okay, in this on this worksheet, I'm going to use this frequency distribution to estimate the mean and the standard deviation of the original data set. So the emphasis here is that we don't have any of the original data. We only have this frequency distribution. And from this frequency distribution, we could extrapolate very accurately the mean and standard deviation of the original data without having any of the original data. Now, I have the original data on sheet 2. This is the 70 data values, the 70 penny weights from the previous worksheet on, I think it's just called pennies. So we could compare our estimates to the exact values. So let me just get the exact values right now. So mean would be average and standard deviation. This is a sample of data, so stdev.s for sample and standard deviation of this. Okay, so here are our values for mean and standard deviation, but now pretending we don't have any of this original data. We only have the frequency distribution. So this is the frequency distribution. I just copied this off of the earlier the pennies worksheet where we made the frequency distribution in the histogram. So I'm going to use these two formulas down here. This is straight out of the book. This is mean of a frequency distribution, and this is standard deviation of a frequency distribution. This formula looks complicated, but just keep in mind on top you've only got three numbers. You have n, that's a number. You've got this thing, that's one number. And you've got this thing right here, that's one number. And then we square it. So I've highlighted these cells up here in green. These are those three numbers. N, the sum of f times x, and the sum of f times x squared. So these three green boxes are going to be these three numbers. N, sum of f times x squared, sum of f times x. So these three numbers here, these three boxes here. Okay, so first for the mean. The mean is the sum of f times x, so frequency times data value, divided by n, where n is the sum of the frequencies. So these x values, remember x stands for data values. We don't have any of the data values. So for these x values, we estimate them by the midpoint of each class. So the midpoint, I'll say equal, we're averaging out the lower and upper bounds. So lower bound plus upper bound divided by 2. So that will give me the midpoint of the first class. So that's my first x value. And I'll use Excel to just copy that formula down to do all of the other calculations for me. Okay, for n, that's the sum of the frequencies. So I'll do sum of these frequencies on top. And there's our 70. And I need f times x for each x value, and then I need to add them up. So over here equals frequency times the x value. And I can copy that down to repeat those calculations, and Excel will add them up for me with the sum formula. So equal sum of all of these numbers. And so this formula is saying take the sum of f times x, that's this 186.95, divided by n, which is the 70. And that should be the mean of the distribution. So number one, how many data values are accounted for? That's going to be the 70. Find the mean. That's going to be, according to the formula, the sum of f times x divided by n. And if I go over here to sheet 2, let me actually copy these values over. So for the mean, I have 2.672 and the standard deviation 0.192. So down here, 2.672 and 0.192. So these are the exact values I got from the original data over here on sheet 2. Original 70 values, calculated the exact mean and the exact sample standard deviation. So our estimated mean is very, very close, within 1/1000th of the exact value. And so next question, what are we actually doing here? So like what is this formula doing? Well, it's taking the average of 70 numbers. And what are those 70 numbers? Well, here's one x value, 2.445. And we have 18 copies of that. So I could copy this down 18 times, down to row 18. So there are the, let me do this. So there are the first 18 x values. Then the next x value, 2.545, there are 19 copies. So 2.545, and copy this down 19 times. Next x value, there's none of those. Next would be 2.745, and we have 2 of those, so I'll just make 2 copies there. Next x value, 2.845, and I have 22 copies of that, so I'll copy that down 22 times. And the next one, 2.945, and I have 9 copies of that. 2.945, and copy that down to row 9. So this is the 70 estimated data points. These are the 70 estimated values. So I don't have any of the original data, so I'm estimating these original values by using the midpoint of each class and estimating, well, 18 copies of this, 19 copies of this, and so on. So I should get the exact same value as what I got for number 2, because I'm basically just working out the details of this formula. So over here, this will be equal to the average of all of these numbers over here. I'll just click and drag and highlight. So average of everything on the right, average of those 70 numbers, I get exactly the same as part 2. So part 2, I just use the formula up here. So that's the quickest way to get through it. But in part 3, I did this just to sort of get an understanding of exactly what's going on with this formula and why this gives you the average. Okay, next for standard deviation. So again, I'm coming over here. We need n. We need the sum of f times x squared, and we need the sum of f times x. So up here, I need each of the individual frequency times x value squared. So I'll say equal f times the x value raised to the second power. And I'll copy that formula down. So those are the individual f times x squared, f times x squared, f times x squared, and so on. So I will add them up, equals the sum of those values. So now these 3 green boxes of 70, the 186.95, and the 501.8638, those are these 3 numbers up here in the numerator. So for standard deviation, let me scroll up just a little bit. So according to this formula over here, the standard deviation is equal to the square root, and I'll use another set of parentheses for the numerator, n, which is 70, times the sum of f times x squared, that's the 501, minus the sum of f times x to the second power. Here's the sum of f times x. So minus the sum of f times x raised to the power of 2. Okay, and close parentheses, that's the numerator of the fraction, and then divided by the denominator, n, which is 70. So I'll put that in parentheses, 70 times n minus 1, which is 69. So I have n times the sum of f times x squared, that's the f9, minus the sum of f times x, that's the e9, raised to the second power, close parentheses, all divided by, again in parentheses, n times n minus 1, 70 times 69. Oop, I found a typo. Oh, I forgot the last. Sorry, I forgot the last parenthesis. Yeah, close the parentheses on the square root. And so there again, here's the exact sample standard deviation, 0.192. Here's our estimate, 0.193. And again, this estimate in number 2, estimate of the mean, number 4, estimate of the standard deviation, is coming from it's coming from this frequency distribution that contains none of the original data. We're just using estimated values. So all 70 values are gone. These are our estimated x values, and we're able to get estimates that are within 1/1000th of the actual exact values for mean and standard deviation. Okay, that about does it for this one.